Okay, so let's start. So today's topic that we are going to cover will be correlation and regression. So is my screen visible to all of you?
Yes, sir.
All right. So our today's topic is correlation and regression. So before starting the topic, let's discuss what is actually correlation and what is regression. In our day-to-day life, in different sorts of statistical problems that we solve, we have to deal with a lot of data, right? Let's say we are given a certain set of data, and then we are given a certain set of another type of data, and then we are asked to relate that, okay, what's the relation between this set of data and what is the relation between that set of data. So correlation and regression, they actually allow us to relate between these two sets of data. Let's say in our metric level or in our intermediate level, we have learned about straight lines, right? So in straight lines, what was the general equation? It was, let's say, something like y is equals to mx plus c. So here, as you can see, here m slope is the constant and c, the intercept of y-axis, this is also a constant. So basically, we are making a relation between y and x. So basically, we are writing y as a function of x. But unfortunately, in our day-to-day life, the real-life problems are not similar, okay? We might be given a set of data. Let's say if I am running a company which sells books. So I'm selling books. So I have a set of salesperson who actually sells the book, and I have a statistics on the number of books which have been sold. One, let's say his name is Rohim. So he has received 40 customer calls and he was able to sell 120 books. Okay. Similarly, we had another salesperson whose name was Korim. He has received, let's say, 36 phone calls and he was able
আসসালামু
to
আলাইকুম
sell.
স্যার
ওয়ালাইকুম
ওই যে
আসসালাম।
অনেক অনেকে ইয়াতে আছে স্যার অ্যাকসেপ্ট করেন না এখানে
ও আচ্ছা। All right, so let's say we have another salesperson whose name is Korim. So he has sold, let's say, 240 books. And then let's say our third salesperson, let's say his or her name is Jannat. So she has received, let's say, 50 phone calls and she has sold 320 books. So we have two sets of data. We have the number of phone calls received by the salespeople and the number of books sold by each of the salesperson. So let's say this is my y data and this is my x data. So now I have to make a relation between y and x. So I want to express y as a function of x. So regression model is basically a process or a method of making a relation between two variables. So let's say I have two variables, which is x and y. I want to relate them. So regression allows me to make a relation between these two variables. Let's say I want to make a relationship between y and x. I want to write y as a function of x. So this is basically a regression model. Let's say my relation is y is equals to 2x squared plus 3x plus 6. Okay. So here this is a mathematical equation. Let's say a quadratic equation. So it allows me to write y as a function of x. It tells me how with the variation of x, y will vary. Okay. So that's what regression model is all about. It helps you to actually relate the two variables, and you are able to actually write the two variables as a function of each other. So that's how we can write y as a function of x. So this is a common example of regression models. Now, what is correlation? Correlation is an expression of accuracy. So what does it mean by the expression of accuracy? By the term expression of accuracy, okay, first let's learn how the correlation coefficient is actually mentioned or denoted. Let's say the correlation coefficient It is denoted as R. Okay, smaller. So correlation coefficient value, it varies from -1 to +1. So what does it mean if the correlation coefficient varies from -1 to +1? So correlation coefficient is basically an expression of accuracy. So it means that how accurately the regression model captures the behavior. Here, as we have mentioned, that we have two sets of data. One is the number of phone calls received by the salesperson, and another is the number of books sold by that corresponding salesperson is given as Y. Okay. So let's say we have made a regression model. Okay, let's say this is our regression model. So on that basis, the correlation coefficient of the regression model, it tells us that how accurately or how precisely this regression model will able to capture the varying data. Let's say if our regression model is, if our correlation coefficient is, let's say R is equals to 0.81. Okay. So since it is 0.81, it means 81% of the behavior of the given data has been captured. Okay, which means 81% of the behavior of the given data has been captured. So what was the rest? Let's say the rest of the 100 minus 81. So rest of the 19% of the data cannot be captured because of some irreversibility, or let's say, or any kind of adverse condition or any kind of uncertain behavior. We could not capture the rest of the 19%. So the closer the value gets to 1, the higher the stronger the correlation. Okay, so let's start our presentation. All right. So correlation analysis is basically a group of techniques to measure the association or relation between two variables. As we have mentioned in the earlier example, we have seen that let's say we have two variables, one is y and another one is x. So if we want to relate these two variables, so the correlation, it helps us to associate these two variables. So in every correlation and regression modeling, we have two types of variable. One is the dependent variable and another one is the independent variable. So let's go back to our write-ups. So in this expression, our x is actually the independent variable. It can vary independently, while the y variable is actually the dependent variable. As we are writing y as a function of x, so we can call it that y is the dependent variable and x is the independent variable. Okay, which means it can be varied independently. As we want to know that let's say if someone receives 40 phone calls, then we want to find out that what was the number of books that he has sold. If we want to find out this kind of information, so in that case the number of phone calls will be the independent variable and our dependent variable will be the number of books sold. Okay, so this is how the dependent and independent variable can be distinguished. So here we have two examples. Let's say this is also a straight line and this one is also a straight line. So one has a negative slope and another one has a positive slope. And one of them has a positive correlation and another one has a negative correlation. So what does it mean by a positive and a negative correlation? So positive correlation means, so in one word, correlation is basically impact of the dependent variable. So let's say you have made a regression model. Let's say your regression model is somewhat like y is equals to f of x, and your correlation coefficient is r is equals to plus 0.76. Just assume that the correlation coefficient is plus 0.76. So here, positive means the dependent variable has a positive impact. So the dependent variable has a positive impact on the the independent variable has a positive impact on the dependent variable. That is, if I increase the value of x, let's say if my x value is increased, then proportionately the y value will also increase. Okay. And if my x value is decreased, then similarly my y value will also be decreased. So this is what positive correlation means. If my correlation coefficient is positive, it indicates a direct proportionality. So if my correlation coefficient is positive, I can understand that the correlation or the relation is directly proportional, which means if my independent variable increases, variable will increase. Similarly, if my independent variable decreases, then the independent variable will positive correlation indicates the relation. Now let's say my correlation coefficient is R, let's say minus 0.64. Okay, so this means that the relation is inversely proportional. So negative correlation means the independent variable will have an adverse impact on the dependent variable. So what does it mean by an adverse impact? So let's say if my independent variable increases, let's say I have another correlation, let's say I have another regression model, which is y is equals to f of x. So let's say my x value has been increased this time. So in that case, will my y value increase or decrease? If my correlation coefficient is negative, will the y value decrease or increase? If I increase the x value?
Decrease, sir.
Yes, it will decrease. As I have mentioned earlier, as it indicates an inverse proportionality, that means if my x value increases, then the y value will be decreased. And just the vice versa. If I decrease the x value,
Y value would be increased.
then the y value will increased. Yes. So this is what these two graphs actually indicate. Let's say, all right. So here we can see two graphs. One, here the correlation coefficient is positive. You can see that with increasing value of x, the y value increases. On the contrary, as you can see, the correlation coefficient is negative. That's why with increasing value of x, the y value decreases. So this is what the sign of the correlation coefficient indicates. So have you understood the significance of the sign of the correlation coefficient? What happens if it is positive and what happens if it
Yes,
is
sir.
negative? All right. Now let's talk about the value. We know what happens when the sign is positive or negative. Now let's talk what is the significance of the value. So if you closely look at this chart, it shows that the correlation coefficient varies from -1 to +1. So the more it is towards the 1 value, the stronger the correlation. So as it mentions that if you have a -1 value, then it means a perfect negative correlation. If we have a +1 value, then it is a perfect positive correlation. And in between, and the closer the value towards 0, then the correlation becomes weaker. Okay, as you can see, if it is positive but close to 0, then it is a weak correlation. If it is negative but again close to 0, let's say minus 0.1 or minus 0.05, then it is considered as a weak negative correlation. So the value of correlation, the correlation coefficient or the magnitude value, it actually determines how strongly the parameter or the input parameter or the design parameter, it affects your design or the affects your output parameters. So why we do this correlation analysis? In order to analyze, let's say, in your product design or in case of any kind of engineering design projects, you will be dealing with plenty of input parameters. So as an industrial engineer using statistical methods, you would love to find out that, let's say, if I am designing, let's say this is my, so as I am from a mechanical engineering background, my common research topic was, let's say, power plant engineering. Okay. So in a power plant engineering, the most common output parameters are, so my output parameters will always be Y. So common output parameters are, let's say, the thermal efficiency, or how efficiently my power plant can convert the biomass fuel into usable electricity or electric power. And let's say the cost. The cost can be either in dollar or it can be in Bangladeshi taka, whatever it is. Okay. Let's say these two are my indicating output parameters of a design power plant. While in case of input parameters, so for regression modeling, always remember the input parameters will be written as X and the output parameters will be written as Y. So my input parameters can be anything. Let's say the ambient temperature. Let's write it as X1. Then it can be pressure ratio. This can be written as X2. Then we have, what can we say? Let's say we have turbine inlet temperature. Which can be written as X3. And let's say the mass flow rate. Let's write it as X4. So we have 4 input parameters, while our power plant output parameters are written as thermal efficiency and, let's say, the cost. So these are my output parameters and these are my input parameters. So as we know, what does regression model do? Regression model allows us to relate let's say we can write y1 as a function of x1, x2, x3, and x4. Similarly, we can write y2 as a function of x1, x2, x3, and x4. Okay. So when we are dealing with any kind of design problem, we want to know that which input parameters are the most effective one, or which input parameters are the most critical one. Let's say you have done a statistical analysis and you have found, let's say when you are correlating y1 and x1, you have found a correlation coefficient of, let's say, plus 0.72. Let's say when you are correlating y1 with x2, you are getting a correlation coefficient, let's say, minus 0.4. When you are correlating y1 and x3, you may write it, you might have got a correlation coefficient of, let's say, 0.99. Again, if you are correlating y1 with x4, you are getting a correlation coefficient, let's say minus 0.64. Okay, let's just assume that after doing the statistical analysis or after doing the regression modeling, you have found these correlation coefficient. So what does correlation coefficient indicates? It indicates that how the input parameter affects the output parameters. So let's say your correlation coefficient is 0.72 here. Here it is minus 0.44. Here it is 0.99. Here it is minus 0.64. So as I can see, so from this statistical analysis, what are the things I can conclude? So from this statistical analysis, I can conclude that first, since I have a positive correlation with x1 and x3, I can write that x1 and x3 should be increased for better Y value. So for any power plant, the thermal efficiency is definitely a desirable property, right? You want the thermal efficiency as high as you want. So here you can see that your thermal efficiency, as I am denoting thermal efficiency as Y1, and I can see that the correlation of thermal efficiency with X1 and X3 is a positive one. So I can tell that if I increase the X1 and X3 value, which means my thermal efficiency value will increase. Okay, so that is why I can conclude that X1 and X3 should be increased for a better thermal efficiency value. Similarly, as I can see that with the correlation with X2 and X4 is negative, that's why X2 and X4 should be lower for a better Y1 value. Okay, why? Because X2 and X4, they are negatively related. As I can see, there is a negative correlation, which is minus 0.4 or let's say minus 0.64. So from here, I can conclude that if these two values are lower, then my thermal efficiency will be increased. What is the other thing that I want to conclude from here? Another thing is that as I'm already done with the sign convention, now let's look at their magnitudes. So from these four values, what do you think? Which input parameter is the most impactful one or the most critical one? What do you think from these correlation coefficient values?
R3.
Yes, R3, because it has a very strong correlation of 0.99. So the closer the value is towards 1, the stronger the correlation. And which one has the least impact on all these input parameters?
2.
R2, yes, because it has the lowest magnitude, which is 0.4. So the closer the value is towards 0, the weaker the correlation. Okay, so this is a very simple example to teach you how the statistical analysis actually helps us to identify which parameters are impactful, which parameters are critical, which parameters can be neglected or you might neglect while designing the problems. So using these correlation coefficients and regression modeling, you can actually comment on these input parameters. Okay, so these set of parameters are more impactful, these set of parameters are less impactful. So this is how you can choose. While you are as industrial engineers, you are definitely into the optimizing different systems. So when you will be optimizing, you can actually prioritize that. Let's say this input parameter has the highest correlation, so I will put more emphasis on this one. Or let's say this input parameter has a correlation of, let's say, 0.04. Okay, which means it has a very negligible impact on the performance of the system, right? So therefore it can be neglected or less preference can be given on this parameter. So this is how you can prioritize. This is how you can actually set an order of preference when you are optimizing, or let's say if you are designing any system, you will be able to set a standard or order of preference based on which input parameters will be you will be prioritizing. Okay, so this is basically the purpose of correlation and regression modeling. Is it clear up to now?
Yes, sir.
All right, so let's move on.
কয়েকজন একটু জয়েন করার
আচ্ছা।
জন্য ওয়েট করতেছে।
আচ্ছা আচ্ছা, okay. So here, as previously mentioned, we have an example. So we have been told, let's say in this column, we have been named the sales representative or sales people. Let's say Tom Keller, Jeff Hall, Brian Virus, whatever it is. I have taken this from a book. And here on the second column, we have the number of sales calls that they have received. Let's say Mr. Keller has received 20 calls, Mr. Hall has received 40, Mr. Virus has received 20 sale calls. So in this way, these sale calls have been listed corresponding to their names. And on the last column, the number of books or the number of copiers that they have sold has also been listed out. Let's say Mr. Fish has sold 60 copies, Mrs. Susan has sold 30 copies. So each of their sales call record has been listed down, and also the number of copies that they have sold has also been listed. So now, let's say the company wants to find a correlation or a regression model which actually relates the number of sales call a representative is receiving 2 with the number of books he is actually selling, just like the earliest example I have shown you. So let's say the company wants to find a relation between the number of calls received and the number of books sold by a representative. So my number of copy has been mentioned as Y, and my sales call has been represented as X. So here is a very simple plot of X and Y based on this data. So this is basically the data plot, very simple data plot, as you can see. So before telling you about this plot, let's just solve a very simple problem. Okay. So before moving on, we have a formula for the correlation coefficient right at the top of the slide. I have already mentioned the correlation coefficient formula. So what's the formula? It is R is equals to X minus X bar, summation of X minus X bar into Y minus Y bar divided by N minus 1 into Sx into Sy. So let's first find out what is the X value, what is the X bar value, what is the Sx value, and Sy value. All right. So X and Y, these are the values of the observation, okay? Values of the present observation. So what does it mean by the values of the present observation? Let's say we are dealing with observation 1. In that case, my X value will be 30 and my Y value will be 20. Again, if let's say I am dealing with observation 3, let's say I am dealing with the observation of Mr. Virus. So my X value will be 40 and my Y value will be 20. Now, the X bar and Y bar value, let's say this is X bar and this is Y bar. So these are basically the mean or average of the entire column. Okay. So what is the X bar and Y bar value? It is basically the mean and average of the entire column. So how do we find the mean? We just have to sum up all the values along the X column. Let's say if I want to find out X bar, I have to sum up all these X values and basically divide it by the number of observations. So let's say my number of observation is N. So if I want to find out X bar, I will simply sum up all the values of X and I will divide it by N. Similarly, if I want to find out Y bar, I will just sum up all the value of Y and then I will divide it by N. Okay. So this is how I will find out the values of X bar and Y bar, which is the mean of the entire column. And what is Sx and Sy? These are basically the standard deviations. So Sx is the standard deviation of X column. And Sy is the standard deviation of Y column. Okay. So we know how to find out the standard deviation. The standard deviation is basically Sx will be square root of summation of X minus X bar whole square divided by N minus 1. Similarly, Sy will be square root of summation of Y minus Y bar whole square divided by N minus 1. So this is how we can find out the standard deviations of the X column and the Y column respectively. So I think we know pretty much how to find out each and every value. So after we are done finding each of these values, we just have to plug in these equations. Okay. So let's see. All right. So just one of you use a calculator and tell me the value of each of these. So let's say you can take a screenshot of this one and tell me the value of X bar and Y bar first. Just sum up the values of X and divide it by N.
Sir, X bar equal to 22.
All right. So my X bar value is 22. And what's the value of Y bar?
45.
45. Thank you. So I have my X bar and Y bar value. Now, what I have to do is, okay, so I have to find out the standard deviations as well. So just look into this data and using your X bar and Y bar values, tell me the value of the standard deviation. You can use a calculator if you want.
Sir, the standard deviation for the X column is 8.71.
Okay, so standard deviation for X column is 8.71. And what about the Y column?
Y column is 450.
450. All right. So now we know our X bar value, we know our Y bar value, we also know the N value, and Sx and Sy has also been obtained. So what you have to do is you have to use the summation of X minus. So first you have to find out the product of each of the observation, which is X minus X bar and Y minus Y bar. And then you have to sum them up, or you have to sum up all of them. Okay. So if I go to the here, as you can see, they have multiplied X minus X bar with Y minus Y bar, and they have summed them up. So as I can see, the summation is equals to 900. So if I just plug in the values, so my R value will be equals to summation of X minus X bar multiplied by Y minus Y bar divided by N minus 1 into Sx into Sy. So my summation of this entire portion is 900. N minus 1 is basically 10 minus 1.
So there was
Yes.
a small mistake. The SY value would be 13.6.
Oh, thank you.
13.6.
13.6. Okay. So it should be 13.6. So Sx value was 8.71 and Sy value is 13.6. So someone please tell me what's the value of correlation coefficient.
Zero point 0.84.
0.84. All right. So my correlation coefficient is 0.84, which means, yeah, since my correlation coefficient is 0.84, it's pretty much close to 1. So we can say that it's a very strong correlation coefficient. Okay. So if I give you certain types of math in the exam, what you have to do is you have to make columns. Let's say your Y and X column will be on the left side, and then you have to make another two columns, which is X minus X bar and Y minus Y bar. Then you have to do the product of these two. Okay, X minus X bar and Y minus Y bar should be multiplied, and then you have to write the value and list them out, and then you have to do the summation, pretty much like the frequency distribution table that you have done earlier in the course for your basic statistical analysis. So please show these detailed calculation, and even if you make some small mistakes while calculating, then it will be easier for me to detect that where you have made the mistake, so that I can give you more marks in the exam. Okay, so try to show it in this detailed manner so that it will be easier for me to understand, and it will be easier for you to get more marks in the exam. So I don't think there is any more confusion on how the X minus X bar and Y minus Y bar multiplication value was obtained. And I think the correlation coefficient is also obtained, which is 0.84. All right. So this is our correlation coefficient value. Now let's move on to another value, which is the coefficient of determination. So coefficient of determination is basically the square of correlation coefficient. So let's say our coefficient of correlation coefficient value is R. So our coefficient of determination will basically be R square, which is 0.84 square. Okay. Someone please tell me what's the value of 0.84 square?
So 0.7056.
0.70. Let's write it as 0.70. Okay. So our coefficient of determination is R square equals to 0.70, which means 70%. If I convert it to percentage, it is 70%. So coefficient of determination, it indicates that what portion of the behavior has been captured by the regression model. Okay. So if our coefficient of determination is 70%, which means that the 70% of the behavior has been captured by the linear regression model. As we are working on linear regression models, so if our coefficient of determination is 0.70, which means 70% of the behavior has been captured by the linear regression model. The rest of the 30% would not be found out because, let's say, lack of data, too much variation, or let's say deviation. It can also be uncertainty. So due to these reasons, we could not capture the remaining 30% of the behavior, but rest of the 70% of the behavior has been captured by the linear regression model. So this is what the coefficient of determination actually implies. Okay. So I think if I ask you that what is the coefficient of determination and what is the coefficient of correlation, and if I give you a certain set of data, I think you will be able to find them out in the exam hall, I hope. All right. So now let's move on to a regression model, move on to the regression models. So in this course, we will be mostly working on linear regression models, but let's say in your future research works or let's say any kind of thesis, you might also have to work on curved or nonlinear regression models as well. And nonlinear regression models are mostly performed using software. So as we are mostly working on analog or handwritten based solutions, so we will be mostly dealing with linear regression models. But I might, at the end of the semester, might give you some assignments related to how to develop the nonlinear regression models or regression models, which includes, let's say, multiple variables. So you will eventually learn, even in your upcoming courses, let's say in your third year or fourth year courses, you will also learn how to do the regression modeling using different softwares. Let's say Minitab, it can be MATLAB or any kind of Python or any kind of software. You will learn how to make regression models for complicated relations which are not actually linear, but a lot more non-linear or exponential form. So in this particular course, we will mostly focus on linear regression models. All right. So when we are making a linear regression model, let's just write a general form of regression equation. So a general form of So the general form of linear regression can be written as y is equals to ax plus b. Okay. So just like in our matrix level, we used to write y is equals to mx plus c. Here we can write y is equals to ax plus b. Okay, our meeting might end after 15 minutes due to the shortage of time. If the meeting ends, I would request you to please rejoin using the same link. Okay, I will also rejoin and we will continue where we have left. So this is the general form of our linear regression model. Let's say y is equals to ax plus b. So we have our dependent variable y, we have our independent variable x. Now what are the values of a and b? How do we find out the values of a and b? So let's just see a couple of formulas which helps us to find the values of a and b. Okay. So as you can see at the top, b is actually the slope of the regression. X column. So this is a value of x bar. Okay. So using this formula, you will already know the value of b, right? So if you know the value of b, you can just plug in the value of b in this equation. You know the value of y bar, which is the mean of the y column, and you also know the value of x bar, which was the mean of the x column. And if you know the value of b, you just plug in the values in this equation, and you will also find out the value of a. So let's just go back to our previous problem. So in our previous problem, what was the value of sy? The value of sy was 13.6. The value of sx was 8.71. And our value of correlation coefficient was 0.84. So just plugging in these values, someone please tell me what's the value of b. What will be the value of capital B, which is the intercept of y? So I think I have made a mistake while writing the general equation. It should be a plus bx.
1.31.
1.31. Okay. Okay, I have given a slight correction, which is I have made a mistake. The equation should look like this: y is equals to a plus bx. Here b is the multiple or the slope along the y-axis, and a is basically the intercept of y-axis. So please make this correction. So my b value is 1.31. Okay. So if I know the value of b, and I also know the value of x bar and y bar. My x bar value was 22, and my y bar value was 45. So now just plug in these three values here and tell me what's the value of a.
16.14.
16.14. Okay. So our b value is 1.31 and our a value is 16.14. So from here we can write our generalized regression linear equation is y is equals to a plus bx. So if I just plug in the values, my a value is 16.14 plus 1.31 times x. Okay. So this is my equation basically. Y of f of x is 16.14 plus 1.31 x. So using this equation, we can actually capture the behavior of the data that we were provided. Let's say if we want to relate the number of phone calls with the number of copiers sold for each representative, then using this linear regression model, we can actually capture the behavior, or actually capture a part of the behavior or of the given data we were provided. Okay, so this is how we can construct the linear regression model. So in your exam, if you solve up to this, you will actually get the full marks. If I ask you to, if I give you two sets of data, let's say if I have given you the x value, if I have given you the y value, all you have to do is you have to solve the problem by finding out the correlation coefficient, and then you have to find out the a value and b value. So please show the detailed steps. It will eventually make it easier for me to give your marks. And after that, when you have found out the value of a and the value of b, then you can actually find out the linear regression model, which actually captures the behavior of the given set of data. So once you are done by solving this, just write the equation in this form. Then I think that will complete the solution. Okay. Have you understood how the problem has been solved? If you have any questions, then please tell me.
Sir.
Okay. So I think this is a very straightforward problem, and you can actually expect pretty similar problems in your exams. Although in this problem, let's say in the exam, I might just change the scenario, or I might just change the, let's say, the circumstances. Let's say in this problem, we had the number of books and the number of phone calls. Let's say in the exam problem, I might give you the relation between, let's say, how many centimeters of rainfall has taken place on a certain date. So you have to make a correlation between a certain day and the amount of rainfall that has taken place on that certain month. Okay, so this is how you will be able to make correlation coefficients and regression models, which actually captures the behavior. All right, so what is the purpose of actually making regression models? It is for using to forecast. Okay, so using these equations, we can actually make a forecast or make a prediction. All right, so this is my equation. So I know that if a representative or a salesperson has received X number of phone calls, then he will be receiving Y number of, or he will be selling Y number of textbooks. Okay, now using this same relation, let's just rewrite the relation, which is Y is equals to 16.11 plus 1.31x. Okay, let's say if one of my employees has received X equals to, let's say, 24 phone calls. Okay, so just plug in the value of 24. What will be the number of books he has sold?
So 44.96, that means
Oh, so
45.
44.9, you can round it up to 45. So using this relation, phone calls, so then he has definitely sold 45 textbooks or 45 copiers. Okay, so this is how we can actually forecast or we can project. Similarly, let's say we have a regression model which relates, just a simple example. Okay, in this case, your X is the number of day. In a month, we have 30 days, right? Let's say your number of days written as X, which varies from 1 to 30, and Y is basically the average rainfall in centimeter. Okay, so if we have developed a regression model, let's say a linear regression model, which is Y equal to fx, which is written as a plus bx. So using this linear regression model, on a given day, let's say I want to forecast what will be the amount of rainfall, or how much rainfall will take place on the third day of the month. So if I just plug in the value of 3 in this equation, I will be able to find out what will be the average centimeter of rainfall taking place on that particular day. So this is basically the purpose of developing regression models. It is to actually capture the behavior and eventually predict, forecast, or project any kind of future outcomes using these regression models. Okay, so based on your accuracy, the more accurate your model is, the more likely it is to predict actual values, or the more likely it is to have a value which is closer to the actual one. Okay, so we are not much concerned about the accuracy of the models at this stage. We just want to learn how to develop these regression models. So in your exam, as I have mentioned, that you can expect to face similar types of problem where I will give you two columns, let's say X column and Y column, and I will ask you to form a regression model, and I might ask you to find out the correlation coefficient and also ask you to comment, okay, what does this correlation coefficient actually means? Now let's go back to the plot. All right. So as you can see, so if I draw a linear regression line along this path or along these dots, let's say this is a best line of fit. Okay, so as our correlation coefficient was positive, as you can see, with the increasing value of X, our Y value actually increases. Okay, apart from a few exceptions, let's say this one is an exception, let's say this one might be an exception. Apart from a few exceptions, we can actually confirm that since the correlation coefficient was positive, that's why we can tell that with the increasing value of X, our Y value will eventually increase. Okay, so that is why I'm talking about this plot at the final stage. So in the exam, I might ask you to, let's say, as you know the X values. Okay, since your X values are given, using the same regression models, I want you to find out the Y values again and make a plot. Okay, so these are already the plots which have been plotted based on the actual value, but I want to make another plot which is based on the regression model and then compare if there
So
is too much.
the another plot will be a straight line.
Yes, a straight line. And in your intermediate or metric level, you have heard this term, which is the baseline of fit, or let's say baseline of fit. Yes, so this is one kind of baseline of fit which actually tries to capture the behavior. yes, it might not intercept all the points, but it will intercept a few points which actually falls within that straight line, and rest of them can be considered as exceptional. So in your exam, I might give another extension asking that you will plot these two y values and compare the values, okay? And then tell me that why there is so much variation or why this is so accurate. On that basis, you can actually comment that since my correlation coefficient is, let's say, only 70% or 0.7 value, so since it's very less, that's why there are too many variances. If it was, let's say, close to 0.91 or 0.95 or 0.99, then this correlation coefficient value would mean that the plot from the actual value and the plot from the regression model would have been more or less similar. Okay, let's just see an example. Let's say this is my y-axis and this is my x-axis. So let's say this is my line from the regression model and these are my points from the data. Okay. So if my correlation coefficient is, let's say, closer to 1, let's say 0.9 to 0.99, then these points will be very close to these straight lines. Okay, the actual points will be very close to the regression model. On the contrary, if the correlation coefficient is very less, let's say 0.1 to 0.6 or 0.7, then there will be plenty of variance. Okay, the points might be somewhere here, someone might be here, someone might be here. So you will see that the difference is vast. So if I ask you that why this vastness or why this difference or deviation has occurred, then you will comment on the basis of your correlation coefficient. As my correlation coefficient value is less, that's why my correlation is weaker. So due to this weak correlation, leads to more deviation. While a strong correlation provides an accurate value or lower deviation. Okay. So this is basically the significance of the correlation coefficient. So after making it two distinct plots and after comparing them, you will actually comment based on your correlation coefficient. Is it clear up to now?
Yes, sir.
Okay, so I think our content is done. I will provide you the slides and I will also ask you to solve a few problems from the textbook. I will also provide you I think I have given you one textbook. I will also suggest a few problems from the textbook. Okay, so can you give the class test tomorrow? The first class test that was pending, if we have offline classes tomorrow.
Yes, sir.
Okay, then please prepare accordingly. If we are given offline classes, then the class test will take place, and if we still have to continue with the online classes, then we might have to wait for another week. So please prepare accordingly. Okay, so I think we can conclude here, and I will not take any attendance. I will give all of you the attendance today, so no worries. Thank you, everyone.
Assalamu alaikum.
Assalamu alaikum, sir.
Wa alaikum salam.